Okay, this is the last, and it has a couple of questions that are a little bit more challenging that require us to think a little bit more, but it was the exam from November 2019, so the national exam. So let's just take a look at it. The first question is a little bit strange. They made a question that was even easier. It's normally out of 5 marks, now it's out of 4 marks because it's even easier to do. It says determine f prime of x from first principles if the function is just 4 minus 7x. Well, first principles, you just got to know that you got to write down that formula. I didn't put it down there, but it's f of x plus h minus f of x. So that's all you do. Instead of x, put in an x plus h. You've got that formula in your formula sheet, and it tells you to go f of x plus h. So instead of x here, put x plus h. 4 minus 7 times x plus h. And then you've got 7 times, this is minus, this part here is just f of x. I almost want to take a picture of that back here. Oh, there it is. That's the formula that we have to do. The limit of f of x plus h minus f of x over h. You're given that formula, and that's all I'm using here. There's f of x plus h. I put x plus h in for x, and there's f of x, and I'm minusing it. Well, we just multiply it out. We get minus 7x minus 7h minus 4, and there, be careful, minus minus is plus 7x. And just like always, things cancel. The 4's cancel. Minus 4 minus 7x plus 7x. All you're left with is 7h, but it's minus 7h. Be careful there, it's minus 7h, so that the h's cancel. Gee, the gradient is just always minus 7. That's your answer. Well, that makes sense because this is a linear equation with a gradient of minus 7. And you go x to the 0, you'd x to the 1 rather, you'd multiply it in front, you get minus 7, and then x to the 0 is just 1 there. But there it is, even using the shortcut method, that's how it works. Let's take a look at the next question. It's pretty straightforward. Find dy dx if y equals 4x to the 8th power plus the square root of x cubed. Well, your first job is just to put this, and there's really a 2 out there, make it 3 over 2. There's your answer. And now that it's in the right form, you just multiply it in front. The derivative is, there's the function, the derivative of y with respect to x is 8 times 4 is 32, and 8 minus 1 is 7. And that's all there is to it, 32x to the 7. And then 3 halves times 1 is 3 halves, x, and then 3 halves minus 1 is a half. And that's all there is to it. That's it, done. Now the next question is you got to be a little bit careful. Hey, they haven't given us numbers, they've given us letters there. Oh, those look like variables. That's kind of making me nervous. Find dy dx. Well, the only thing it says find the derivative with respect to x, then the only variable that's changing in the derivative is the x value. Pretend that a, or actually you could treat a like constants, as if they were numbers, 5x squared plus 5 or something. So you treat a as if it was a constant and just focus on the x values. So then you'd go 2 times a, and you'd bring it down 1. 2ax would be the derivative. That's it. But what about if the derivative with respect to a? Then you treat x squared as if it was a constant, and just do the derivative of, like x squared is the coefficient sort of, and find the derivative of a. Well, how would that work? Well, the derivative of a is just 1, so you just have 1x squared. And the derivative of this a is 1. 1 times a and bring it down 1a to the 0. So your answer for the derivative of y with respect to a is x squared plus 1. That's a little strange for most people. But if they say dy dx, pretend that a are just constants, like numbers, like 5 and 5, and then just do the derivative thing. But if they say the derivative with respect to the other letter, pretend the x squared's a constant. Just leave it there as a number. Just leave it as x squared. And work out the derivative of a and a, which is here. It's 1 and 1. Okay, a little bit weird, but that's how you do it. The next video, we're going to do a question that's a little bit more challenging.